Hey guys, how's it going? Just a quick video before I jump on a plane in a few hours. We've got no webcam today. We're talking about Tetra again, and more specifically, we're talking about Osmo-tetra. And this is an interesting project because if you guys actually go and check out Team Midnight Blue's YouTube page, they are the research team that cracked Tetra a few years ago. You'll see that they're actually using Osmo-tetra. Well, more specifically, they're using TE Live, which is a fork of Osmo-tetra, and I'm fairly certain that TE Live was so good that the Osmo guys just absorbed the entire code base into Osmo-tetra now, so they're essentially one and the same. So yeah, if we minimize my browser now, you guys will see that I've got my Airspy R2 connected. If you guys are most probably using an RTL-SDR, that's fine. I'll show you guys how to configure that as well. But for this tutorial, I'm using my Airspy. And I've got a bunch of commands in this text document here. I'll put them in the description and the comment below. And we'll get started by clearing my terminal window. And I'll paste the command to actually fetch the Osmo-tetra program files. The second command we need to run is a combination command of, so we're cding into the Osmo-tetra /source directory, and then we're just going to make it. Run the make command, and that'll build all the binaries and libraries and stuff like that. And then the next thing we need to do is we need to open up GNU-Radio Companion. Now this is going to be the RF front end. So once we configure this flowchart, it'll export a Python script, and then we'll run this Python script to tune into the Tetra signal, and then it will forward packets to a UDP port on our computer. So I'll just make sure that all of this is right for you guys. Yep, that is all good. And the first thing we really care about is changing the sample rate. So if you're using an Airspy R2, you need to actually change that to 25 followed by 5 zeros. If you're using an RTL-SDR, don't change this, just leave it at 2 megasamples per second. So I'm going to hit apply on that. And then the second thing we need to change is, I believe it's this one here. And then I'm going to change it to, as you can see here, I've got a Tetra base station frequency here. 464.194. And I think it's 1, 2, 3, 4 zeros after it. No, that's wrong. It's 3 zeros, sorry. And we can see here that I've got my frequency for the Tetra base station downlink. Now, this is an unencrypted Tetra base station too, by the way. There's no encryption on Tetra in my entire city. And there's probably about maybe more than 10 base stations to decode, so that's really fun. Just give me 2 seconds here. Fairly certain that's correct. Okay, so the next thing we need to do now is we need to generate the flow graph. Now generate is this circle with the small arrow, so we're just going to press that, and then we should get a success message down here in the log. And there's 2 ways we could do this. We could just hit play directly, and we can see here that this window opens up. This is called the FFT window. And we can see here I've got a very, very nice Tetra signal here. And there's also another way to run that as well. So we can actually close this now because I've already generated the flow graph, right? So when you guys generate the flow graph, it's in this folder here, sorry, I should say. This is the GNU-Radio flowchart that we just used. And then it will actually output this Python script here. So we can actually run that Python script just directly from our terminal window here. I can paste that there. And then there we have it. That is our RF front end receiver running. So that's 50% of the tutorial now. Now we actually need to run the demodulator portion now. So to do that, we actually need to edit one of the scripts used. So I'm going to open up another terminal window here. I'm going to paste this featherpad command here and we're going to edit the file called receiver1 UDP, which exists in the source folder here somewhere. That one right there. So we're going to edit that. I'm going to activate the line numbers, and then we need to scroll down to line 62 and 65. And where you can see this text here saying /tetra rx, we need to add, without the quotes, this text right here. So -d/temp. So we just make sure we're in the middle. We paste that there. And then we also need to do the same on line 65 as well. So after you've modified these two partial commands there, we save the document and we close it. And this is it. This is the tutorial almost done, guys. So I'm going to paste this command here now, and that's going to actually run the demodulator portion. So in a nutshell, what's happening here is this is the RF front end. It's sending Tetra data to a UDP port on our computer, and then this script here is just demodulating it, and it's going to decode the data and print the data in the terminal window here. So we can just hit enter on that, and there we have it. I'll just maximize that so you guys can see what's going on. We've got Tetra frames there, and the main difference between all the other decoding apps is we don't actually get the raw frames with their binary bits like this. So that's really cool. I'm assuming that's why the Team Midnight Blue guys use this, because I have a feeling that getting raw Tetra bursts is a good way to extract a keystream. So I don't know how to do that yet. Extracting the keystream to run through the cracking tools is something that is unclear at this stage, and the Team Midnight Blue guys are not going to release that tool. So, but I think this is a good first step anyway towards achieving that. So yeah, that's really cool. That's Tetra there for you guys. So I'm going to just hit Control-C and quit this, and then I'll restore that. So if you guys want to actually capture those frame bursts to a file, I've got a command here for you guys. And essentially, this is just the exact same command we ran above, except it's going to write the captured data to a text file in our home directory here. So I will just run that command. And you can see here that we've actually got a file here called bursts_, and that's got the current time, which is 37 minutes past 2 in the afternoon on the 9th of September 2025. So that's pretty cool. I can just probably open that up. This file will grow in size exponentially large, probably get to about 10 megabytes in only a few minutes. And then there we have it. That is all of our decoded Tetra data. So yeah, anyway, that should be enough for you guys to get started now. I'm going to put all these commands and stuff in the pinned comment and the description of this video. So make sure you guys go and check that out. And yeah, that's really all I've got for today, guys. So yeah, have fun decoding Tetra in Linux. I'll do a follow-up, more in-depth video at a later time where we'll do some voice decoding and we'll capture some data and decode it. Like we'll capture data to a C file and then we'll decode it after the fact. And that'll probably be the point of the video where I actually ask if anybody out there can actually capture some encrypted Tetra data for me in a C file format, and then send it to me so I can have a look at it. But yeah, anyway, that'll do it for this video, guys. So thanks very much for watching. I'll see you in a week or two. Bye.